Welcome to NCBOLD 2020 Scratching the Surface. My name is Jessica Esposito, and I am glad that you are here. You can access this presentation through the QR code or using the bit.ly. And here is the bit.ly, bit.ly/Scratching the Surface 2022. Feel free to make a copy of the presentation so that you can have it to use it in the future. Our session description. It's time to throw out those copy and pasted research student slide deck presentation. Partnering learning and research with coding excites and engages students. This interactive I do, you do and playground style session will provide opportunities for participants to explore how to encourage student choice through research-based coding projects. No coding experience necessary. You'll experience hands-on coding technologies like Scratch, BeeBots, and ProBots. This Mentimeter is good for just 7 days, so if you're watching this at a later date, you will not be able to access this information. How are you feeling today, Cow Style? I recently read Moo by Sharon Creech, and I was inspired by that book. For this, how you feeling? I'm number 6 today. I'm smiling and excited that you're here, and I hope that this helps you. Again, my name is Jessica Esposito, and this is all about me. I am the Digital Learning and Innovation Specialist for Alexander County, and I love to bring coding to students in the classrooms. Feel free to contact me at any time. My email is below, along with Twitter. You can also contact me through Twitter. And I would love to hear from you, and I hope that this helps you. Scratching the surface. All of this was inspired by using Scratch and a virtual field trip that I took with my students to the Riverbank Zoo. This is highlighted, or it's a hot link, so that you can make a copy of the entire project for your students to use with your students. And I'm just waiting for it to load. So this project was completed with second grade students, and over the couple of years, or the past 2 years, we worked on this project, and I'll get into more examples with you later, but you can see here that students explored the virtual field trip. They were able to choose an animal and then create a coding project using Scratch. The digital learning standards for students and teachers are here and linked. All of this links back to standards, and it's standards-based alignment. And if you need access to this, I do have these hot links in the presentation that you can access. Just feel free to pause the presentation and explore the standards. This project is also linked to language arts, speaking and listening, and geography for second grade. And I have listed all of those links here. So here are 2 more hot links. Again, this is the Riverbank Zoo Google slide deck that you are more than welcome to make a copy and keep for yourself and use with your students. And I also have a copy of the s'more that I created for the students and their families using s'more. So the second grade animal research project, so we researched this information this project. It was a second grade Scratch, using Scratch and coding projects. So here are the students. We went to the computer lab each day for a half hour during their intervention time, and the students researched and coded their favorite animal from the Riverbank Zoo. And you can see here, they were excited. They loved it. They could not wait every day to come to the computer lab and create their coding project. So I'll show you a couple of them. This is Abby's. So what the students did is they researched, they used a graphic organizer to write down all the facts that they learned about the animal, and then they created the coding project and they inputted or typed in the facts that they learned about the animal. I'll show you another one. Now the black-footed cat is not in Scratch, so the students had to use the paint part of Scratch and create their animals to look like the black-footed cat. So they spent a lot of time creating the cat. And then same with the Komodo dragon. There is not a Komodo dragon in Scratch, so they had to again use paint to create the dragon, or as close as they could get to a Komodo dragon. There you go. And so what they needed to do was create a background that was as close to the animal's habitat. They had to type facts about the animals and then have the animals move back and forth on the page. There was not a background for, no, there was a background. So there was not a sea lion, and Elin was not able to create a sea lion using paint, so he put in a person, a student, and had the student in the correct habitat. You are welcome to pause the video and look at more of these projects if you would like. You are more than welcome to do that. I hope you enjoy their projects as much as we did. Here I have copies of the Freyer model that we use for their research. You are more than welcome to make a copy. I used Google Drawings to create these graphic organizers. And so you can see here that the students had to record their physical features, the life cycles and lifespan, their offspring, their diet. And here where it says animal, they wrote in the type of animal that they were researching. So that was page 1 of the graphic organizer. And page 2. They also had to be able to describe the habitat, and this was important because with the Scratch program, they needed to come up with the background, and they either had to create the background that was appropriate or they had to find a picture that was already created in Scratch to have the correct habitat for the animal. They also came up with 2 fun facts about the animal, and then they had to draw a picture of the animal. I also have linked for you the Google Drawings and Graphic Organizers that was created by the Catawba County ITFs. And you are more than welcome to share this resource and make a copy of this resource. There are other graphic organizers. If you do not want to use the Freyer model with your project, you are more than welcome to use a different one. Of course, it's your project, but I did want to share these with you in case that you were interested in using something different. The project timeline. So I went during intervention time with the second graders. I had a half hour each day for 3 weeks. Day 1, we explored the Riverbank Zoo website and the students chose an animal. Day 2 through 9, and that's flexible depending on the student. They researched their animals, they completed the graphic organizer, and I did make them go back and fix the graphic organizer if they did not have the correct information or if they did not have information filled out for the different sections. So some students took all 9 days and some students did not need 9 days. We used NCBOLD Cloud, Britannica, and EBSCO. We had library books from our local library and our public library. And I also had appropriate websites that students could look at. I did check all of those websites prior to the project, and then I updated the links each year for the past 2 years because some of the links did not work this year. And then approximately day 10, we explored the scratch.edu.nit website. I did give them 1 day to just play in Scratch and have fun and learn about it. I showed them different things, but I also wanted them to have free time using it. Day 11 through 15, they completed their final animal research coding project. That did take about 4 days. We had some technical difficulties if our internet was not working correctly. And then also students had some difficulties with the habitat and with the animals and had to use paint to change things. So that did take our 4 half-hour days. When I'm planning these projects, I think about the 4 C's. And this is a picture from Amy Soma. I think about communication. How are the students communicating with each other? How are they collaborating? Using critical thinking and creativity. And what I love about Scratch is that it definitely lends itself to all of these, especially the creative part. And then SAMR, using the tech tool as a creation, a new task, which was previously inconceivable. So if you think about it, students used to do their research and fill out the graphic organizer and write a paragraph or more, or create a presentation. And then we moved to Google Slides. And then the students were just putting all of that information in the Google Slides, maybe drawing a picture with it or inserting pictures. Now with Scratch, students can not only fill out their graphic organizers, put in all of their sentences, and then create the habitat, the scene with the animal and have that information in there. And this picture is from Jonathan Brubaker's blog. And I love how he has that laid out so you can see the different steps in creating for students and using technology as a tool for creation. What is Scratch? Scratch is from MIT, and I'm going to play you an introduction video. You can pause the presentation and play the video yourself, but I am going to play the video for this presentation.
I was searching for interactive programming language on the internet, and I came across Scratch. As soon as I shared my first project, I got instant feedback, and I was like, okay, I want to continue with this.
I remember my first project was a super simple animation. I'm still actually really proud of my first project. It opened my eyes to the different possibilities that coding can present.
So I've been drawing basically since preschool when I learned how to hold a crayon. I think making art with Scratch is different because I can collaborate with other people and make something interactive that other people can use.
There was a song that said, "Happy, happy birthday." I put Scratch in there. It just became an instant hit on the site and inspired so many people to make their own songs and remixes.
Anyone can do anything with my project, and sometimes it's really funny how they change things at the end. It just goes to show like how much you can actually do with all the things you have in Scratch.
When you're looking at other people's projects, you're engaging on such a different level, which really encourages this kind of mindset of seeing yourself and each other as makers of things and not just consumers.
But I never thought that I could do like the coding part. Like I thought like I have to wait till I'm a grown up and like hire someone to code it for me. But then I was like, hey, I can actually do this myself.
It gets more complex, but once you know the basics, you can add on to your knowledge and move at your own pace.
If you like solving problems, if you like drawing, if you like making music, if you're into anything, Scratch is for you.
So one of the things that with this project the students might have to do is create their own animal. So for example, the black-footed cat and the Komodo dragon, they did have to create their own animal or modify an animal that was already created in Scratch. So Scratch does have some characters or sprites as they call them, but the students may have to, depending on which project, use paint. So I'm going to share this video, play this video for you. It's how to make a character design in Scratch.
Hi everyone, it's Zoe from the Scratch team, also known as Zinnia. Today I wanted to show you how to make a character designer in Scratch. Basically, it's a kind of project where the player can customize their own character of whatever kind. If you've ever seen a game that's like, make your own cupcake or design your own fox, this is that type of game. And by the end of this video, you'll be able to make your own game like this. Let's get started. So first, let's pick what you want the theme of your project to be. Do you want to make a design your own cat game, or design your own dragon, or design your own outfit? It can be anything you want. As an example, I'm going to make a create your own dog game, but this video will work no matter what theme you pick. So first, we're going to draw one version of the character in our game. If you haven't drawn much in Scratch, or you don't really enjoy drawing, don't worry. I'm going to show you a drawing style that's really easy to do and actually doesn't require any drawing experience. To draw a character, I'll hover over Choose a Sprite and click Paint. Here's the drawing style I find really easy to use. I basically make the character out of simple circles. I'm making a dog, so I will click on the circle tool and drag out an oval-ish circle thing to be the head. Then I'll click on this purple square to change the color to black, and now I'm going to draw small circles for the eyes. One thing I like to do is once I've drawn the first eye, I will click on it and click Copy, and then click Paste, and now I have a second eye, which I could just put over here. So I could have a purple dog in my game, but I think I want the dog's fur to be brown. To change the color of this circle, I just have to click on it to select it, and then click this square again. To make a brown color, I'll switch the color up here to something in the orange section of the rainbow, and then I can change the brightness to get a darker shade of brown. Okay, so now I want to give the dog sort of floppy ears. How do you make shapes that aren't circles? What you can do is make a circle with the circle tool, and then click on the point editing tool, and you can click and drag on these points to mold the shape into the shape you want it. So to make floppy ears, I'll drag this point over here, and maybe this goes over here. And I can also click on a point and move these arrows to control the shape around that point. So that's how I draw shapes that aren't circles. I start with a circle, and then I'll just move the points a little bit. And now that I've drawn one ear, I can click on it, and just like with the eyes, I can click Copy and Paste. And then now I have a second ear, and I can also click flip horizontal so that it's pointing this direction. Now I'll set the color to pink and draw a circle to give my dog a nose, and I'll use the eyedropper tool to get the same color I used for the head and draw a circle for the body, and I'll drag these points down a little bit so it looks like it's sitting down. And I'll give the dog a tail. So for that, I'll make a circle and then move this point this way and move this. Okay, so we've drawn one version of our character. And you, of course, don't have to draw what I did. It can have totally different parts. You could have one of the parts be a donut and one be the frosting on the donut, or cat ears and a cat's face, or an ice cream cone and an ice cream scoop. And you can make all these shapes out of really simple circles and rectangles. So how do we make this a character designer game where the player can actually modify the character? So you see how the character is made up of these different parts? I'm going to take each of these parts and put it in its own sprite, like a sprite for the ears and a sprite for the tail, and then the player will be able to mix and match them. So here's how you do that. Pick one thing that's going to be a part of your character.
So you can see here that Paint allows students to create their animals how they want to create them, and allows them to change or modify their characters or their animals depending on which project you want to do. Scratch also has directions on how to use pixel art, creating virtual pets, a virtual town, games. They have so much on their YouTube. It is amazing. Also, what's important with this project is creating a background or having the correct habitat for their animal to live in, but also how to create their backdrops. So Scratch does have backdrops or backgrounds that are already preloaded that students can just pick from, but students can also create their own if they want to. And I have a video for you, or Scratch has a video for you to view that.
Hi everyone, it's Zoe from the Scratch team, also known as Zinnia. Today I wanted to show you how I draw really simple backdrops in Scratch. Adding a backdrop to a Scratch project has this ability to really set the scene, and I have found that there are really simple ways of drawing an effective backdrop. So that's what I wanted to show you today. Let's get started. To draw a backdrop in Scratch, just hover over this button that says Choose a Backdrop and click Paint. I found that a good base for drawing a backdrop is to create two rectangles of different colors. One to be the sky or the wall, and the other to be the ground or the floor. So if I was doing an outdoor scene, I would probably do a blue rectangle for the sky, and the way I would do that is click on the rectangle tool, change the color to blue, and drag out a big rectangle. I usually click here to edit the outline and make there be no outline on the shape. And then to make the grass, I will set the color to green and drag out another rectangle sort of on the bottom. And then once I finish the base, I like to add one item in the backdrop. And I usually like to create this item with either the circle tool or the rectangle tool. So what's something that could be in an outdoor backdrop? I could add a rock to it. So if I click on the circle tool and set the color to gray and then drag out an oval and click on this tool to edit the points of the shape and move the bottom point inward, yeah, that looks like a rock. And I could even change the color slightly and make another smaller rock next to it. And there you go. That's a pretty simple backdrop, and it's really quick to make. So, for drawing your own backdrops, one way you can start is by thinking of two colors for your scene. If it's an indoor scene, it could be a yellow wall and a blue floor. If it's a city scene, it could be a brownish-reddish wall and a gray street. If it's a scene in a spaceship or a secret hideout or something, it could be a light gray wall and a dark gray floor. And then you can think of some small object or detail to add with the rectangle or the circle tool. A flat brown rectangle could be a shelf in a house, and you could even put a square on top of it, and then that looks like a vase on the shelf. Some flat rectangles of a slightly different shade of brown could be bricks on a wall. A light blue rectangle could be a window in a house, and a dark blue rectangle could be a window in a spaceship out to the night sky. One particular type of object you might want to add is a plant or a bush or the leaves of trees, and I have found for this that the paintbrush tool is really helpful. So if you have this color set to green, you could click on the paintbrush tool and just draw sort of squiggly rough lines. They don't have to be anything in particular. Make some squiggly shape and fill it in with the fill bucket. And then that could be a bush, you could make a plant, you could even make sort of the canopy of leaves at the top of the forest, which could give the idea that your scene is a forest scene without you having to draw every single tree. For any object that you'd like to have a rough edge, I definitely recommend experimenting with the paintbrush tool. And lastly, let me show you how you could get started with a top-down backdrop, a backdrop where your project is seen from above. What I'll do for a top-down backdrop is just do one big rectangle for the base ground, and then just draw paths with the paintbrush tool set to whatever color I'd like the paths to be. And you could even use the circle tool or the rectangle tool to create shapes that would be seen from above. Anyway, there are so many ways to draw backdrops in Scratch. I wanted to give you some ideas that could give you inspiration, but you can take these ideas in any direction you want. See what you like drawing and what works for your characters and your projects. I'll see you next time, and Scratch on!
So like Zinnia said, it is endless. It is infinite. Students can be so creative with what they create. So I look forward to seeing what your students create.
Hi everyone, it's Zoe from the Scratch team. Also,
this one is for a moving background, so you are more than welcome to pause the video or pause this recording and watch the moving background one or scrolling background. And she goes through all of the steps for creating a background, and then at the very end she adds how to make it scrolling. So if the students want the background to be moving and keeping their sprite in place, they can do that also. So we started with very simple coding for the students. And that is, this is what I said that they had to have their basic coding, was that when clicked, they had to put in the forever loop, have their character move 10 steps. If their character had a costume, they could put in next costume, because some of the animals, for example, the butterfly changes, and then wait 5 seconds and then do the next costume if on edge bounce. And then that means that when the character moves, it bounces back and they don't get stuck at the end of the screen. And then you can see here under say hello, the characters or my fish went back and forth and they said hello. So adding the say, that is where the students will type in their sentences for their projects. And then here is an example. And you can see that the fish are moving back and forth and it does say hello. Here is more for students who are creating games. This is a lot of coding. This is for a specific game. There are other things that you can do with Scratch. It does not have to be an animal project. I just happen to do the animal project with my students, but I wanted to share some other coding that you can do with the students. So if you are doing, for example, a geometry lesson or area and perimeter, the students can create a game that through coding, it goes from point A to point B. And here is all the coding for that example. There are more examples on the Scratch website that you can go through and look. So step-by-step design, when you're thinking about creating something, choose your standard or standards. What is your essential question? Books, stories, or digital resources that I used the NC Digital Library, NC Ed Cloud, formerly NC Wise Owl, and then I used Scratch. I also included the graphic organizers for you. And then decide on your final products of learning. What digital project would you like them to create? What do you want them to be able to do digitally at the end of the project? And then design the steps in learning. And then this was an area where you could share your projects. Or that is the project, excuse me. That is the project that I use. That was my end design. And then here's a Padlet. I would love, no matter when you are watching this or listening to this presentation, the Padlet link is open. You can either scan the QR code or click on the link for the Padlet and share your ideas. What would you use? How would you use Scratch in your classroom? And you can see here I have other examples. And then I have share Scratch creation links. So if you create a Scratch product, you can put in a link to share. And I would love to see what you create. And then here I have built in 15 minutes. If we were live or together in person, I would give you 15 minutes to create with Scratch. So what I would like you to do is pause the video, pause this presentation, and then go into Scratch and create. I look forward to seeing what you have to share. And then again, here is the Padlet link. And then, like I said before, you would, if you did create something, I would love for you to put in a link on this last section, share Scratch creation links. I have built in for our in-person presentation a 5-minute break to set up for ProBots and BeeBots and allow, because this is originally, or it's going to be an hour and 50 minutes presentation in person. So this would be a time for you to pause, go take a break, get a glass of water. I hope you enjoyed the Scratch part of the presentation. Please feel free to email me if you have any questions. All right, BeeBots. I am excited to share BeeBots with you if you haven't already used BeeBots. They are programmable and rechargeable screen-free coding tools. I love BeeBots. Our students love BeeBots. We have sets of BeeBots in all of our elementary buildings, schools. So the BeeBots have very simple coding. They are excellent for K2 coding projects. We have also used them 3.5 as an introduction to coding. So if you look at the BeeBot at the top, they have a go forward, they have a right turn for 90 degrees, they have pause, they have a go backwards one, clear memory, and turn left at 90 degrees, and of course the go button. Very simple coding. They also have on the back side, on the bottom, sound on or off. So it's up to you and how you want to have the sound on or off. Here are some dancing BeeBots. This is just one example of coding that you could use with your students. And can you imagine the coding, the critical thinking that the students had to do. They all had to code their BeeBot to do the exact same thing and then line them up and make sure that they go in the correct space. Just think about that. Forward, backwards, 90-degree turns. A lot of critical thinking going on there. Here is another one that I love, this YouTube video. It's 5 BeeBot ideas. I'm going to play this for you. So there was a lot of ideas in that, 5 ideas about BeeBots, how to use BeeBots for early coding ideas, and taping a pen at the back of the BeeBot to have some art so that the students can see their coding in real time. So we have the BeeBot challenges in our elementary schools. So these are students from Alexander County learning to code using BeeBots. And I will say these lessons with these students have really turned into several more lessons. So they not only are they coding and learning to code, but now these students have become interested in bees. So the media coordinator has had a lot of, or many, I should say, many lessons about bees and how bees are in real life, in the real world, and then they're coding the BeeBots to act like bees. So this has really taken off at her school. Here are some students from our Alexander County schools, and they are participating in one of our STEAM days, geometry and coding with BeeBots. So they reviewed geometry lessons, and then they created the BeeBot to go around their shapes. So they were making different shapes and then coding the BeeBot to go around the shapes, and they loved it. Here are students from Alexander County participating in STEAM Day, geometry and coding with BeeBots activities.
I hope it's gonna work. Please don't let We've been doing this for like 10 It finished once, and we had to do it again. I was trying to see it.
So you can see here, they were challenged to do 2 parallel lines together at the same time. And then the boys were challenged with creating a geometric shape and then having the BeeBot go around it. Here are students from Alexander County Schools completing makerspace challenges with BeeBots and Kiva planks. So you can see here they were challenged to build something with Kiva planks and then have the BeeBot go through it. And then here are students in Alexander County Schools reviewing shapes and using BeeBots, learning how to code using BeeBots and going from shape to shape. Hear how excited students are and how they are actively engaged using the BeeBots, reviewing their shapes. They are collaborating, communicating, thinking critically, and being creative in how they get the BeeBots from one shape to another.
Okay, now it's my turn to program.
Clear it.
Are we done? Here's some clearing. That's all. Alright, you ready? Go. It probably will. Never say never. Oh my yes, this is working. No! Oh my that is hard.
So this is where I would, if you were in person or if we were in person, I would pause it and give you 15 minutes to play with the BeeBots and experiment with the BeeBots. You can pause the video and rewatch anything that you would like. I'm going to move on to the next thing. So I have here some information about BeeBots. I have links to where you can purchase the BeeBots at Terrapin. This is Terrapin Online. This is where you can show information about the BeeBots and learn about BeeBots and coding online. Here I have a link to BeeBot lessons. And what I like about San Francisco, this is from San Francisco, in each of these lessons they have units on the BeeBots and they also have Scratch. Here they have BeeBots and Scratch. They have different lessons and more BeeBots. And they also have unplugged computer science. So they have units online for everyone to use. I also have a blog from Generation Robots. I have linked to their website and they have 50 different lessons using BeeBots. And this is by Allison Lydon. And here are the BeeBots. And you can see here they have planning, they have information, they have pictures. They have story sequencing, Guess Who games, I Spy. They have 50 different lessons. And at the very end, they also have more pictures for you to use. They have everything here for their lessons. And then I also have another blog that I found, or excuse me, a YouTube video about how to teach math, 5 BeeBot math lessons from YouTube.
When I started my business in 2000,
those links are there for you. And I also have built in a 5-minute break time so that we could set up for ProBots if we were in person. So you are welcome to pause the video for the break time or keep going. ProBots. ProBots are the next step from BeeBots. So what's been working really well in our elementary schools is going from BeeBots to ProBots, and the students are loving it. So we are using the BeeBots K5, introducing coding, learning how to code with the BeeBots, and then right now 2nd grade towards the end of the year with ProBots, but move quickly 3-5 using ProBots. We also have ProBots in our middle schools and high schools. So ProBots are being used across this county in all areas, and I have examples in this. What are ProBots? Just like BeeBots, ProBots are programmable and rechargeable screen-free coding tools. So you can see here with the ProBots that they have a numeric pad. They have the arrows, so forward, backwards, left turn, right turn. They have built in a pen holder, which I love. They do have light sensors. They have scroll buttons. They have a menu button. They have an LCD panel so students can see their code as they're typing it in. They also have a procedure button, a repeat button, and a rear touch sensor in the back of the ProBots. The ProBots use rose art markers. You can buy them on the Terrapin website, and you can also purchase them on Amazon. Do not use other markers with them because they will get stuck. Do not use pens. They will get stuck. Rose art markers. So I have linked in the presentation the ProBots training manual. So the controls and the buttons, it can hold up to 128 commands. They have the go and the stop, and like I said in the previous one, they have the forward, backwards, left turn, right turn. They also have the numeric. So unlike the BeeBots only turned at a 90-degree angle. The ProBots, you can program it to do turns anywhere between 0 and 360. It is amazing, and I have examples of that later in the presentation. Here is a YouTube video of a gentleman describing ProBots.
Hi, this is a ProBot robot. It's a great little robot which can do loads of maths with. To switch it on, the little push button at the bottom. Its lights will flash and main will come up on its display. To drive it, easy as well. You press the forward key and you'll see FD in the main window will come up. Then the number of centimeters you want to go, like 10. And you press go. Lovely. If you want to add another command, you press right. Let's say we want to go right. And if we want to go right 90, you press 90. The command is RT 90. And now if I press go, we'll see 2 commands, the forward 10, the right 90. Great. What do I do if I want to go back now? Well, you move these keys here so that you're at the end of your commands, and then you press the back key And let's go to 10. Now we've got 3 commands in. We've got a forward 10, a right 90, back 10. It's no surprise you press the left key to turn left, and I won't bother going through that. There are a few other things to note. If you want to delete a command, you press clear and press it a few times to get rid of it completely. Now I've only got 2 commands in. The other button, which is worth remembering at this stage, is pause. Pause, just here. If you put pause in, it will create a time delay. You put pause and maybe 5 seconds, and it will stop for 5 seconds in the command. Excellent. So it's just a matter of starting it at the beginning with the go command. It's waiting 5 seconds, and then it's going to go back. That's lovely. If you want to stop it somewhere, you just press go during the operation and it stops the program. And that's all you need for this lesson.
Very simple, easy to use, and screen-free ProBots.
Hi, this is
About ProBots, this technology was created by Logo Technology and offers students with a new engaging hands-on experience to practice multiple disciplines, including robotic controls and computer programming. All of these statements were written by Zachary Richardson. He is a teacher in Alexander County. The ProBot is a new tool that encourages student collaboration and is an inviting concept to the world of robotics and computer science. And ProBots are used as a tool to demonstrate to the students the application of their thinking. The ProBots as a drawing tool are used to deepen students' thoughts. And then here is a link to data that was taken from a survey in Mr. Richardson's classroom with his students this year. Just taking a moment to load. And you can see here that the majority of the students' engagement survey, that they loved it. And yes, so 86% of his students loved using the ProBots. And then he also had quotes. I like the ProBots because I felt like they helped me learn better. We also got to solve the problems without having to write the problems ourselves, and it was cool to use. I like using the ProBots to learn in a group with my friends. From a teacher colleague that he works with, I really enjoy seeing the students are having to talk to one another about the ProBots and the actions that are happening when they code. I really enjoyed ProBots. They were fun to experience because we were having fun while we did work. I love ProBots. So the students absolutely loved the ProBots in his classroom. Here are some codes written by 4th grade students. So when we asked the students to create some math tasks or to complete some math tasks, these are the codes that they wrote for 90, 180, 270, and 360. And the vocabulary that we used to introduce with the ProBots is obtuse angle, acute angle, right angle, line segment, figure, line, ray, point, perpendicular, and parallel. All of these vocabulary words, not only did they learn the words, but they also were able to use the ProBots to create them, and it really deepened their learning. We also had students coding some more math tasks during their geometry unit, and we asked them to discuss if this is an obtuse angle or an acute angle, create the acute or obtuse angles, solve for supplementary angles, and what code would you use to solve this problem? So we gave them a problem and they were able to create code using it and solving the problem using the ProBots. And the students will see their coding in real time. So when we were working with the students, they created this code to solve the problems. And you can see here is all the code that they created to solve the math problem. And here is the math problem drawn out with the ProBot. ProBots in geometry. The students from Alexander County Schools use the ProBots to learn to code using ProBots and completing their geometry challenges.
All right, explain to me why these are parallel lines.
If we would have made them longer and they would have like kept on going on, they wouldn't have ever crossed each other.
So this video is of students solving math problems in their geometry unit. We used butcher block paper in the classroom. They also had their notebooks to handwrite, but we also were using Flipgrid. So the students each had the job. They have to solve the problem together. They used Flipgrid to record every step of solving the problem. They had to show the code. And then they had to, as you can see on the butcher block paper, they had all of their coding and the drawings from the ProBots. So this is a video that I downloaded from Flipgrid that the students created.
Yeah, that was it.
So they realized
This is what?
It would be
E. Okay, here that
here is F.
so they were moving on to the next problem. So they checked all their problems. Did they solve them correctly?
4 to 15.
And what's great is that students
50.
What's great is that Mr. Richardson was able to take all of the math problems from his geometry unit, and instead of printing worksheets, he took those math problems that they had to solve in the geometry unit and then modified them so that students were able to use the ProBots to solve the problems. And then, of course, all of their math talk, as we called it, was recorded in Flipgrid. So then he was able to see on Flipgrid what the students were doing, how they were using it, how they were solving it, how they talked out and collaborated in their math problems using Flipgrid. And then the butcher block paper was an immediate feedback for the students using the ProBot. So they were able to see their math programs or math problems in real time solved using the ProBots on one large piece of paper. Students worked in groups from 2 people to 4 people, depending on how many students were there that day. There, of course, were absences throughout the unit, but students worked in small groups. Here are more pictures from Mr. Richardson and his students. Using the ProBots, you can see here in each picture that students were using the butcher block paper. They were using protractors. They have the rose art markers. They had the iPads to be able to use Flipgrid and record their math talk and their work. And they worked together and collaborated together to solve each of the problems. They also had to write out their code on the side or under their problems that they were used to solve their problems. Here are some more pictures with the Flipgrid, with the ProBots and the students, and you can see how they wrote their code underneath their problems, how they used the protractors and labeled all of their angles. ProBots can also be used with middle school. We are still exploring ProBots in the middle school, but we have so far aligned it with graphing linear equations, triangles and angle measurements, and inequalities. And here's a picture of a math problem that the students used and labeled and solved with the parallelogram. The ProBots are also being used in CTE classes, and here is one of the challenges that the students were able to create.
Did you pick a star? Unintentionally? What?
And you can see here that the students were creating circles, squares, a triangle, and now a star. And that was in a CTE class, middle school CTE class. Here is some alignment that we are currently working with high school math teachers and how ProBots can be applied to many mathematical skills in grades 9 through 12. Here are some images of CTE high school classes. So you can see here that the teacher or students, created these challenges using painter's tape on the floor, and then the students had to program the ProBots to move through the different challenges. And this is in the video where, or if we were in person, that I would pause and give you 15 minutes to play with the ProBots, create with the ProBots. You are more than welcome to pause the video and go back and look at any of the other videos or pictures. I have links in here for ProBot information. So where to buy the ProBots on Terrapin. They also have, you can buy them individually or you can buy them in groups of 6. I have links to the pens, the Rose Art pens, or markers, excuse me, they are not pens, markers. The ProBot activity guide, I love this. This is on SlideShare. There are 5 things in here, 5 slides where you can get some more information and ideas for the ProBots. Here is ProBot lessons and videos. There are links on this website. This is from BOCES in New York State, and they have ProBot driving lessons, a ProBot teacher guide, and a ProBot user guide that you can link to. They are wonderful. And then I also have links to Blogspot, and there are lessons on here and links for their lessons. And this Blogspot is from Yamini Sukerman. So all of that information is there for you. You are welcome to pause the video and explore. And then I also have linked all of my references that I have used to create this presentation. Again, please feel free to email me or contact me through Twitter if you have any questions, or I would love to see something that you have created using ProBots, BeeBots, or Scratch. Thank you so much for listening.